Okay, it's coming up to 25 to 10 DCFM 88.9. We'll continue the talk right now because he's here and he's organised, and we better do his little introduction. Yes, with COVID being relaxed, I've actually got a body in the studio, and I think it's about the first time I've had a body in the studio. 6 weeks? I'd say so. Anyway, here we go.
It's time now for the latest news on what's hot and what's not in the world of technology with Matthew Dickerson on Tech Talk, here on DCFM 88.9.
Morning, Matthew. How are you?
Yeah, good morning. It is good to be back in the studio, isn't it? It's been a bit strange being in my little homemade studio that we had set up, and we do our interviews via that, and still put our videos out, obviously, but it wasn't quite the same as being in the studio, seeing you in the flesh.
No, that's right, and I'm very pleased to be back, although I can't wear my proper microphone yet. I've got to use the standard fixed one, so that's why I'm looking at you at an odd angle, which people will see on the video. Anyway, mate, look, some incredible stories, and I said to you, why did you put this on your papers at number 8? You say, I'll just do them as they come. But this is an incredible story. Tesla's next battery will make electric vehicles cost the same as petrol cars.
Yeah, that's pretty exciting. And that's obviously one of the big impediments to the uptake of electric vehicles at the moment, is the fact that we've got these unbelievable cars and they're very cheap to run, but they're expensive to buy. And that's still the number one, the ticket price of the car is the number one issue. The main cost of a car is the actual cost of the battery. And so when you break all that down and you say, well, why aren't people taking them up? If we can get that battery price down, we can get the car price down and the uptake will increase. Cobalt is the main cost of that battery, the cobalt in them. So Tesla, in conjunction with a Chinese company, CATL, have put together their knowledge, and they're basically coming up with a battery that's cobalt free. And this will all be released at the end of the month. There's a battery day that Tesla's hosting, and that'll all be released at the end of the month, the exact details of that.
So we've got battery day and B day.
That's right. And so effectively, if they can get that price down, the magic number apparently is about $100 per kilowatt hour of battery. If they can get it below that price, that's when the cost of the car starts to come down to similar, maybe not quite as cheap, but similar price to a petrol-powered car, and that's when I think we'll really see sales start to explode. So that's Tesla and the Chinese company, but there are other companies as well that think they're getting close to that magic $100 figure as well.
All right, well, what about weight? I mean, cobalt is a very heavy metal, and take that out of the battery, you've got lightweight batteries as well.
So that's exactly right. They do actually reduce the weight of the battery. And again, the battery's okay with an electric vehicle because they put the weight all on the base of the chassis. It actually helps the handling of a vehicle when you've got that weight down low.
Yeah.
Now, sure, lightweight is still better, but that hasn't been the biggest impediment. It's really that cost. And so, yes, the cobalt removal will make the batteries a little bit lighter and effectively cheaper, as we said, but the energy density in those batteries as well, that will also make them a little bit lighter so they can pack more energy into them.
So are they going to be, so the cost it will come down equivalent to a petrol-driven car?
It won't be far away, and I think the real issue there is then the manufacturing process, and certainly Elon Musk has talked about the automation. They try to get a lot of automation through the Model 3 process, but they still found they need good old-fashioned humans involved. But the battery production, because it's a much less complicated process, they're also talking about the fact that they'll be able to get to the stage where that battery production will be fully automated, which again will keep the price down. So there's a few things happening here. The cobalt removal, cheaper batteries, more energy per battery, getting the production process faster. And then when you get all those things happening and the price starts to come down, there'll be a trigger point. And suddenly we'll see electric vehicle sales explode. And at some point in the time, and I can't tell you exactly when, but we'll look back and we'll laugh about the days that we used to have to put petrol into a car to drive it around. Remember those old days, Richard? So, it's not far away before that trigger point happens.
It's interesting, and Caltex are probably going to change to Ampol, and that might be a dying thing too. Just on that, though, you've got the Clean Green Western Australian Tractor Company using hydrogen.
Yeah.
Now, is there going to be a problem between hydrogen-powered heavy vehicles and battery-powered heavy vehicles, hydrogen-powered cars and battery-powered cars?
And I think we might end up for a period of time with both electric vehicles and hydrogen vehicles. The great thing about that, though, is that a hydrogen vehicle is effectively an electric vehicle with a slightly different power source.
Yeah.
So they use electric motors in a hydrogen vehicle, and instead of storing in a lot of batteries, they just store it in hydrogen. But over in WA, there are tractors. In fact, there's been tractors across Europe since about 2011, the first hydrogen tractor came out. So across Europe, from say 2012 onwards, we've seen hydrogen-powered tractors. And the great thing about, say, long-distance hauling trucks or heavy machinery or tractors, when you use hydrogen, the refuelling time is much quicker. So with a car, you might have a nice trip down to Sydney or down to Melbourne, you stop every couple of hours, do a bit of a recharge. But for someone hauling transport from Perth to Sydney, they don't really need to stop every couple of hours, just have a bit of a coffee, a bit of a break, and charge their batteries up. So hydrogen's got a huge advantage there in that it's quick to refuel, as is petrol, obviously.
Yeah.
So that's the huge advantage there. But there's a plant in WA at the moment that's producing, or just about to start producing hydrogen, only in the order of, say, 20, 25 tonnes of hydrogen per day. And the idea there will be that they're really using this as a trial plant. They'll be using it in tractors around WA, but if they get the concept right, they'll increase that production fairly rapidly and up to a much larger level. But that's the big thing, is producing hydrogen without burning coal, because you need electricity. So
Yeah.
this particular plant in WA is a completely renewable energy plant, and then that'll produce hydrogen, which will be clean, green hydrogen, which obviously is not much point having nice green hydrogen, but then using coal to actually produce the hydrogen in the first place.
That'll be good, very good. Now, Facebook do incredible things, but this one is super incredible. And I'm talking about their cable, their internet cable. Why, one, an internet cable? Why not a bird, satellite?
Yep.
And two, 37,000 kilometres of it.
37,000 kilometres. When you think about the Earth, the circumference of the Earth is only 40,000 or just over 40,000
That's right.
kilometres. So a 37,000 kilometre cable is a fair length of cable. And this is, Facebook's basically spending around about US $1 billion on this cable to go into the 16 countries throughout Africa. Now, there's huge potential seen across Africa at the moment in terms of internet connectivity. With those 16 countries, you've got about 1.3 billion people, so it's the equivalent of a China or an India. Now, again, not hugely affluent in terms of the income levels of people across Africa, but for Facebook, just the sheer numbers. And there's a whole bunch of people there that just haven't got access to the internet or good internet. And when you look across the world, the average penetration, if you like, for internet access is 6 out of 10 people for good internet. But in Africa, it's only 4 out of 10. So they're running a 37,000 kilometre undersea cable, connecting those countries up, doing it in conjunction with some other companies. Obviously, Facebook aren't specialists in running cables. But the really interesting thing here is that you've got to bury the cable on the bottom of the ocean. You don't just roll on the bottom of the ocean, which I thought would be good enough. But you then get things like a ship might set anchor and suddenly catch that cable if it's not sitting down. Can you imagine calling out the repairman? Look, just out in the middle of the Atlantic there, we've got a little break in a cable. Can you send someone out and just solder that together for us? So it's obviously a completely different scenario. So the reason, back to your initial question, the reason you don't go via satellite is latency.
Yeah.
The satellites sit at a similar distance, 37,000 kilometres or thereabouts. The geostationary satellites, the ones that sit directly above the Earth, they sit at that distance. So when you have that sort of length of distance, you've got this latency because the signal's got to go up to the satellite, back down to the satellite, back in the other direction. And you're also relying on wireless signals, whereas when you run a cable, you're obviously running it in fibre optic cable, so you can actually have the signals much faster, much more bandwidth availability. So, yeah, satellite's good for some areas, but when you're just trying to feed large amounts of data through to an area, then undersea cable is better.
Yeah, okay. Well, obviously they won't employ anybody from Australia because we still use copper.
Yeah, just have a word to the government about that.
Yeah. Oh. Anyway, I've got an NBN now that actually works, but that's another story. The world's fastest camera, very quickly before you go.
70 trillion
What?
images per second.
What?
So our little smartphones might do 1,000 frames per second. So that sounds fairly good. And you see these guys on TV doing 10,000, 20,000 frames per second, 70 trillion frames per second. Now, it's not something we're going to see on a smartphone tomorrow. It is very specialised. They're mainly using it to take photos of things like a nuclear reaction or radioactive decay. So when you've got some of those things happening very quickly, particles in a nuclear explosion are basically exploding at the speed of light, 3 by 10 to the 8 metres per second. So trying to capture that, but it's pretty cool technology that you've got there. And what we'll see is this technology is there in the scientific world today, but those sort of advances and breakthroughs, we'll see those things happening on our smartphones. Not that I think we'll have 70 trillion frames, but the same technology will be used in our smartphones in 5 years' time. The same as Formula One cars, the technology flows into our cars we drive around the streets 5 years later or thereabouts. The same thing will happen with this.
Yeah, the space people who developed Velcro.
Yeah, exactly, that sort of thing. All these developments at the very high end, sometimes people question, what's the good of it to the average Joe Blow on the street? Well, that technology, that development, that research flows down into products we use every day.
I just hope that they don't have to have a nuclear explosion to test the camera. I'm not terribly keen about that idea.
No, that's right.
Matt, always good talking with you for Tech Talk. And in
Good to see
fact,
you in the flesh again.
like the new caps and everything.
That's your out of isolation present, Richard.
Thank you very much. It's a bit hard to wear with headphones because, but anyway, I did wear it for a few minutes for the camera. And we'll see you next week.
Excellent, thank you, Richard.
This is DCFM 88.9 and it's coming up to 9:45 as the music continues in just one moment.